Hey folks, so this is the third video in section 7.3. We're going to start just working some examples dealing with sum and difference identities. The first one that we're going to look at is example number 1, where we're asked to find the cosine of negative 75 degrees. Now, what we have here is, the first thing is that it says that we're looking for an exact value. We've never been able to work with any kind of 75-degree angle without an exact value. So this is something new for us. So normally, if it was 75 degrees, we would just plug that into the calculator. But in this particular case, we're going to use sum and difference identities to do this. So what we're looking for is we are looking for two values on the unit circle that will either add or subtract to a negative 75 degrees. Now let me give you a nice little hint here. Anytime you are working with a negative angle, be it in degrees or in radians, any time you're dealing with a negative angle, what you should do is you should look for two angles on our unit circle, two values that we're used to using on the unit circle that will subtract to get the positive version of this angle. So for instance, something like 120 minus 45, or 135 minus 60, something like that will give you a 75 degrees. And then all you have to do is simply put the smaller value first. So what we're going to deal with here is we're going to work with the cosine of 60 minus 135 degrees. 60 degrees minus 135 degrees. This will give us a negative 75 degrees, where our angle A is 60 degrees and our angle B is 135 degrees. And we're going to use the cosine difference equation or identity that we have. So the next thing we're going to do is just simply plug into the equation. Cos plus sine. So that's going to be cosine 60, cosine 135 plus sine 60, sine 135. And then what I need to do is I simply need to look for those four separate values. I need to look for what is the cosine of 60 using my unit circle. What's the cosine of 135? What's the sine of 60? What's the sine of 135? And plug those in. You'll notice that I've marked my 60 degree angle and my 135 degree angle on my unit circle over here. And so the next thing that we're going to do is just simply plug all those in using our unit circle values. Then we'll follow the order of ops and we will multiply those two terms before we add. So when we multiply this, we're going to get a negative root 2 on top. We'll get a 4 on bottom. Over here on top, we'll get a root 6. And again, we'll get a 4 on bottom. So we'll have a common denominator here. And since it's a common denominator, I didn't write it separately. So we have a negative root 2 plus a root 6 all over a 4. There is no way to combine these terms up here because they are not like terms. All right, let's go to part B, where we are working in radians this time. So we have the cosine of 17 pi over 12. All right, what you want to look for this time is you want to go to your radian unit circle, and you want to find two values on our unit circle that will add or subtract to give you a 17 pi over 12. Now, let me give you a couple of bad examples. For instance, you could use 1 pi over 12 plus 16 pi over 12, and that would equal 17 pi over 12. But unfortunately, I don't know what 1 pi over 12 looks like on the unit circle, so it's not something that's usable. Another option would be maybe 2 pi over 12 plus 15 pi over 12. Now that would actually be a good pair of numbers to use. So let me just write that. That's not what I ended up using here, but let me just show you what that would look like. If I used 2 pi over 12 plus 15 pi over 12, we know that both of those would reduce to a pi over 6 plus, if you divide 15 and 12 both by 3, that's going to be a 5 pi over 4. Both of those are values on our unit circle that we can use. So that's not what I ended up using here. What I ended up using, I'll go ahead and unhide this, is 3 pi over 12 plus 14 pi over 12. So once again, we reduce those two fractions and we're going to get pi over 4 plus 7 pi over 6. So on your unit circle then, we'll mark the pi over 4 And the 7 pi over 6, sorry, my unit circle is not quite showing there. It'll show in just a moment, and we'll plug into our identity. So cos minus sine. So that now there are 4 different values that we need to find from our unit circle. And so when I plug and chug from the unit circle, and this is what I'm going to get, and then I'll do my multiplying first, and then I will do my subtraction after I multiply. So for multiplying, I'm going to get a negative root 6 on top. The other numerator is going to be a positive root 2 all over my common denominator of 4. Now, part C, I love these questions in part C. And the reason I love them so much is because they actually look more difficult than they are. They're quite simple questions. What I want you to notice, this is what I call a work backwards question. What I really want you to notice is that you see I have a cos plus sine. Let me get you back up to the identities that we covered. Cos plus sine. Well, here's a cos plus sine. So what's happened is I've given you this side of the identity, and now what you need to do is you need to plug into this side of the identity. So you see, this is a backwards question. In the first 2 examples I worked, I gave you this side, and we had to convert over to this side. Now we're working backwards. So in this particular case, let's go back down to our example. In this particular case, my angle A is going to be that 173, and my angle B is going to be the 83. And so we'll plug into our equation, cosine of 173 minus 83. Again, that's straight off of the identity, purely plugging into the identity. This is the left side of the identity, and this up here is the right side of my identity. Now let's just go ahead and subtract these two, and 173 minus 83 is 90 degrees. My unit circle says that 90 degrees is up at the top, and the cosine of 90 is 0. All right, we've already done example 2 in the previous video, so if you missed that, go ahead and go back and watch that. Let's jump down to the sine and the tangent, sum and difference, some examples here. So for example number 3, notice once again we're asked for the exact value, in this case of sine of negative 15. So once again, let's use that concept that we used in the first example. Anytime you have a negative angle, just find 2 things on the unit circle that will subtract. Ignore the negative for just a second, and then you can put the smaller one first. So for instance, 45 minus 30 will give you 15. If you put the small one first, if you put the 30 first, that's going to give you a negative 15. In this particular case, I didn't use a 30 and a 45. Apparently, I decided to use a 60 and a 45. So 60 minus 45 is 15. Put the small one first, we'll have 45 minus 60. So this is just showing you that there are two different options. There's way more than this, but there's 2 different options that I've pointed out to you here in just the last 30 seconds. All right, so now let's take this particular part of my identity. Let me bring you back up here. So this is what we have right now, and we want to convert it over to this right side of the identity. So this is going to be sine cos minus sine cos. All right, so we'll have sine 45 cosine 60 minus sine 60 cosine 45. All right, and once again, just like we did in the cosine examples, we've got 4 different things that we want to find on our unit circle. You'll notice that I've already marked them on my unit circle, and so we'll just plug and chug. So here's straight off the unit circle values, and now we just want to multiply in our terms, and then we'll subtract. So in multiplying, you're going to get on top a root 2 minus a root 6 all over the common denominator of 4. All right, let's look at a tangent example. And so for a tangent example, and we're doing a radian example, 13 pi over 12. And so, again, you want to find 2 numbers that will add or subtract to give you a 13 pi over 12, but that will both reduce so that we can use it. So again, a bad example would be something like 2 pi over 12 plus 11 pi over 12. 11 pi over 12 is not something we know how to work with. So you wouldn't want to use that as a choice. So in this particular one, I've chosen 3 pi over 12 plus 10 pi over 12. Let's see, is that the only option? No, you could have chosen a 4 pi over 12 plus a 9 pi over 12. And so there are a few different options that you have for this. Okay, so now let's go ahead and reduce both of our fractions. So that's going to be a pi over 4 and a 5 pi over 6. And so at this point, this is the left side of our identity. And so we'll use the right side of our identity. So let's go back up and look at that identity real quick. That is going to be, we're using this one. So that's going to be tan plus tan all over 1 minus tan tan. All right, so let's go ahead and plug into that identity here. So you see I have my tan plus tan all over 1 minus tan tan. And now what I'm going to do in the margin, and I already have this uncovered here, in the margin I'm going to find these two tangent values, the tangent pi over 4 as well as the tangent 5 pi over 6. Tangent pi over 4, again, you can use sine over cosine, you can use the y value over the x value, but that is going to give me just a value of 1. And the tangent of 5 pi over 6 is going to be, again, my sine value or my y value is a half. My cosine or my x value is negative root 3 over 2. When I invert and multiply, I'm going to get negative 1 over root 3, which then reduces to a root 3 over 3. All right, so now I have what I need to go ahead and plug into each of those. So you'll notice here, let me zoom in. For the tan pi over 4s, I plugged in a 1, sorry, not this one, and this one. And then for my tan 5 pi over 6s, I plugged in a negative root 3 over 3. Now, one thing that I want you to realize, it almost looks as though I've canceled out these ones. That did not happen. That would be illegal. What I did do, though, was I changed my 1s into 3 over 3 so that I would have a common denominator on the top. And I changed it into a 3 over 3 so I would have a common denominator on the bottom. So I did not cancel those with each other. That would have been illegal math. All right, so looking at the top then, this is going to be a 3 minus root 3 over 3. So that's going to be what's on the top, 3 minus root 3 all over 3. And then on the bottom, I'm going to have a 3 plus, because two negatives make a positive, 3 plus root 3 all over 3. So here's my 3 plus root 3 all over 3. Now, this is still improper math because you don't want anytime you have this, you don't want a fraction within a fraction. So let's go ahead and multiply by the reciprocal. So that will be next. So you notice that I took the bottom and I flipped it over. I got the reciprocal of it. And now I can see that my 3's will cancel on top and bottom, so that what's left over is 3 minus root 3 all over 3 plus root 3. I would love to tell you that you're finished, but unfortunately we know that in math it's not proper to have a root in the bottom. So I'm going to need to use conjugates. Remember, you used conjugates back in Math 110. I'm going to use conjugates to get that root out of the bottom. So I'm going to multiply on top and on bottom by the conjugate. Notice this is 3 plus root 3. My conjugate is 3 minus root 3. And as long as I multiply on top and bottom by the same thing, its value is equal to 1, and I'm multiplying by 1. Multiplying by 1 is totally legal. It doesn't cause any problems. It doesn't cause me to change the value of anything. All right, so what we're going to do, we're going to FOIL on top, and we'll FOIL on bottom. And so when I FOIL on top, as well as combine some like terms, so if you need to pause the video and work through that, that's fine. But I FOILed as well as combining a few like terms. I got this, and foiling on bottom, I noticed that my outers and inners zeroed each other out. So I just got 9 minus 3. So continuing to clean that up, I'll have my common denominator is 6. So I got a 9 plus a 3 is what gave me the 12, and the negative 6 root 3, I just simply wrote it by itself there, and then I can reduce both of my fractions to get 2 minus root 3. Some people would have written this as 12 minus 6 root 3 all over 6, and that's totally fine. I just shared that common denominator and made two separate fractions so that I could reduce each fraction individually. So totally fine. I will say, and I think you're already seeing this, that the tangent sum and difference questions, these are more tedious than the sine and the cosine. So just understand that you are going to have a little bit of extra work when you have a tangent, sum, or difference. All right, look at part C. You'll notice that you've got tan minus tan all over 1 plus tan tan. So if I can direct you back to the identity when I have, what was it on top? Tan minus tan. So tan minus tan all over 1 plus tan tan. This is going to be a tangent of an A minus B. So what I've done here is I've given you the right side of the identity in the question. You're going to write down the left side of the identity in our question. All right, so we can see here that our 100 is our angle A, our 70 is our angle B. And so when we write down the left side of the equation, the left side of the identity, it's going to be tangent of 100 minus 70. When we subtract, we get tangent of 30. And the tangent of 30 is going to be, again, sine over cosine, y value over x value, opposite over adjacent. All of these are ways that you can find your tangent. So that's going to be 1/2 over root 3 over 2, multiplied by the reciprocal, and you'll get root 3 over 3. All right, so I'm going to stop the video here and pick up in another video to continue on.